So, hello, this is Kalman Reti, and welcome to my recreation of day 4 of 2023 Advent of Code. I'm going to go to the website. Uh, this is, I do it originally in bed on an Android tablet before getting up. I do it under the covers silently. Um, and then I use the same version of Emacs on my Windows 10 machine to do these recreations. I use a second account so it doesn't look like I've already solved it, but I actually have solved it on my main account. And so this is day 4. And the whole idea is that while we're um, the gardener who's letting you borrow the boat to go look at something has all these scratch cards, and the left-hand part of this set of numbers is the winning numbers, and the right-hand part is the numbers that you got. And so if there's a member here, like this 48, that's over here, that's a winning number. So card 1 has 5 winning numbers, 41. Right, so those are the 5 winning numbers. And of the 8 numbers that I have over here, 4 of them, 48, 83, 17, and 86 are winning numbers. That means card 1 is worth 8 points because you get a point for the first winning number and then you double the number of points for each successive winning number. So that's you've got 4 winning numbers, so that's basically 2 to the third. So if you have n winning numbers, it's 2 to the n minus 1th. So this, okay, so let's start by uh, 2023.04.el, and I have a 2023.04 function that puts in a template that I fill in. And so we're going to use this bit here as the sample input for testing purposes. And we're going to Control X, Control E, sorry, Control Meta E first, then Control X, Control E to evaluate that def-r. For the first def-r, we need our actual input, which is much bigger. So, which I'm going to put here. Control X, sorry, Control E again, we'll do the wrong thing. Control Meta X, sorry, Control Meta E, Control X, Control E. Now I've defined that one. I also need to define these two. The first expression here brings in the common list compatibility package. I use the loop macro, setf, a bunch of things from it. And then this sets debug on quit, which is a feature that normally Control G in the middle of running elisp will just abort. But this will not abort, it'll go into the debugger at the current stack location. You can poke around and do things, including continue. So if you have something that's a long-running program, you can go on. So we're going to have to fill in this function and then call it on the sample input and on the real input to get our answer for part 1. So the first thing that in the solution that I did in the morning in bed, I started out with regular expressions and I got bollocksed up, so I just did a series of split string commands. But I'm going to do with regular expressions because that is a way to ensure that you actually have all the same stuff that you want. So I'm going to first do it manually. So I'm going to Control Meta R to do a regular expression. We're going to search for CARD. then I'm going to search for a space, but there might be more spaces because it looks like they've columnized these things. Um, and then I'm going to, sorry, there might be more, so I don't want the plus, I want a star. Nope, I do want a plus because I do want at least one, but there might be more. So I was right the first time. And then I want a group so that I can capture what's next, which is a number followed by a colon. Now I want another group, um, which is a sequence of numbers before the vertical bar. And so I'm going to do that group, but it's going to be as many numbers as there are. So I need a second group, and I'm going to use a shy group. Uh, the regular groups, you can use an integer index to refer to them and capture the contents, but shy groups are there only for being able to put, plus or star or, some squiggly n, squiggly repetition count on, and the contents are not captured. So what I want is, again, uh, at least one space followed by a number. And I think that's it for the inner group. And I want as many of those as we have. So there's going to be one space number group. This is this shy group. And then we're going to finish the overall group. And we're going to have, and again, a space, which might be multiple, and then the vertical bar, sorry, vertical bar. So notice we are actually successfully matching up to the vertical bar. And one of the cool things about the regular expressions in Emacs is they are remembered, so I can just go back here. And so here we are, again, matching things up to the vertical bar. And so we want to finish the regular expression. Control meta R to regular expression, control R to do the search, meta E to allow us to edit the expression. So I want to basically take this bit that we've got here and duplicate it. So this is going to be a sequence of numbers after the vertical R. And we can see that this now is matching the entire thing. Again, you can quickly make sure that there's no missing matches by doing the search, and the current match is highlighted in sort of pinkish, purplish, but the successive matches that if you kept going, control S, that you would get to are highlighted in blue, but then you can just do a control V and do it again, and page through one at a time to see that you're not missing anything. There would be, a glaring white space if we actually missed any of them. So this is an accurate regular expression. Now again, meta E lets you edit it, which means I can actually kill it. I'm going to put it in a buffer here because if you want it in a string for use in eLisp, the backslashes in the regular expression have to be quoted by a backslash because that's the quoting character inside of strings. So we're just going to say replace string backslash with backslash. And we're going to put a double quote. So here's our regular expression. And we can see that will do the same thing. Search forward regexp. So that moved us past it. We can do it again. So notice we're moving down. And if we go down here, get that one, get that one. And because of the extra arguments I gave it, If we can't find any more, then we return nil. And this is ideal for being in a loop. Um, Now, that's searching in a buffer. You can also do regular expression matches on strings. So a loop for line in split string of input string on a new line. So that'll get individual lines of our input. For, and when you call the string matching regular expression function, which is called string match, um, it takes the regular expression and it also takes the string to put it again, and it returns the position of where the match is, unless 0p pause to debug didn't match. So that would allow us to get into the debugger to see why it didn't match. Now, inside of these groups, for ID string, uh, winning string, gotten string equals loop for I below I from 1 to 3 collect match string. This is the thing that gets you the individual, except I have to actually type an open paren, I, and we need the string because if we did it in the buffer, the emacs would keep remember the matches in that particular buffer and just use that memory. But here we have to pass in the line, um, so it can do the substrings to pull out the pieces that it matched. Um, but we want these in numeric form. So ID winning gotten equals list of CL parse integer of ID string loop for n in stir in winning string, but that's not a Lisp, so we need to do split string winning string by spaces. That's the default. White spaces is the default. Collect CL parse integer of str. And then exactly the same thing, except that we're not doing winning string, we're doing gotten string. And one thing that's often very useful to do is to check yourself. So and we can just sorry, we can just define the function and invoke it, and indeed we see that we for the first of our sample where we had 41 up here, 48, and end in 17, we have the same numbers, and here we have from here 83. In the debugger, if it's too long, it'll give you this ellipsis, but if you just hit return on it, then it'll give you the whole thing. So we can see we have all of the numbers as numbers. So we're good. Now, when I've done something like this, notice I'm moving around at whole expression level, so I don't have to worry about parentheses um, because Emacs is worrying about it. So I'm using control meta forward and control meta back and control meta U and control meta A and control meta E to deal with. And in fact, I could also use control meta T to transpose two expressions. Anyway, so what we need to do is we need to figure out the number of winning ones. So for n n wins equals loop for gotten count member got winning. And so we want to sum, remember I said it was the power of 2 of 1 minus n wins, except that's going to be wrong for if 0p(n) wins 0. So that should be the it. So let's try it on our sample. Again, I often use the trick of Control-U metacolon to insert the answer. And I copied the expression. So that says 13. Let's get rid of our input. And 13 is in fact the right answer for there. So now let's try it on here. One way that you can collect the input for inserting into the metacolon is you can say control meta minus control meta k, which kills the whole expression, and then yank it back. And so that's 2848. It's 24848, sorry. Let's try that and see if that's the right answer. And indeed it is. So the part 2 part is slightly different in that you realize the instructions are on the back of the cards and it's different. Instead of adding up just those points, which were the power of 2 thing, what you do is every time you get a winning card, you get another card, one of each of the successor cards for the number of winning that you have. So the first card had 4 matching numbers, so you get another copy of card 2, 3, and 4, and 5. Card 2 has 2 matching numbers, so you would get a copy of card 3 and 4, but you already had a copy of card 2 before. So the idea is you want to add up how many cards you get. And as usual, sorry, I'm typing to Chrome as if it were Emacs. This is quite easy to do by adding an optional argument and saying part 2, and then defining this as, just calling the first one with the optional argument. And what we need to do is add a memory of how many cards we've gotten extra. So the key of this hash table is going to be the card ID, because that's an increasing order. And so we need, for n wins, this is perfectly okay, for n more equals when part 2 or get hash ID hash table 0. So if we didn't have anything in the hash table, we wouldn't have gotten any extra of this card. The hash table starts out empty, so you'll on the first card you'll always get a 0. But what we're going to do is loop for I from 1 plus ID, so that's the next card, repeat n wins to for element equals get hash IHT if element to incf, just add 1 Else do setf to, ah, we want to incaf by 1 plus n more as well. So let me make that a little less. And then instead of, if it's part 2, instead of, sorry, no, we do would just want to incaf by 1. No, uh, the reason I'm incaffing by 1 plus n more is that if we've got n of these cards already, we have to do it n times. So the 1 is for the current card, and the n more is for the extra cards. And so if part 2, 1 plus n more, otherwise the old thing, and I believe that's, oops. So I must have a parentheses error because I did control meta E, which is supposed to go to the end of the function, but there's mismatched parentheses, so it only went to the beginning of the function. It would have done a control meta F, but then it'll say, oops, there's an unbalanced parentheses, so it doesn't actually get to go to the end. So the loop is what I added. Where's my mouse? My mouse disappeared. There it is. So if I do control meta F here, yep, I left out the last parentheses of this loop. Now control meta E will go to the end, control X, control E will compile it. And first let's check to make sure we haven't broken the original ones. We did. We only want to do this do clause in part 2. So my mouse, there it is. It seems to be pausing frequently. Okay, so we still get 13. We still get 24,848 for this guy. Doing the part 2, oops, so there isn't a part 2 sample, so I have to change it. Control meta U, control meta K. So that says 30. What does the problem say? So in fact, that's the answer that the problem says is correct for the sample. And that's a surprisingly large number. But it's correct. So this was the easiest of 2023 so far, I believe. And moreover, it was one of the ones where the changes between part 1 and part 2 were very minimal. All we did was we added this hash table. We added this clause. Actually, we added one more variable in the loop and this clause for just incrementing how many extra we get of the different cards. And then we, computed the different answer. So thanks for your attention.